Okay, so let's look at this example. This is a definite integral problem from 0 to pi over 6 square root of 1 plus sine x. Okay. So to do this problem, the trick here is you need to think about conjugate. Okay. Why? Because the power of the conjugate is it can help you to generate the difference of the squares. Okay. So if you have a minus b, the conjugate is a plus b. And if you multiply them, you have a square minus b square. Okay. But why we want to generate a difference of squares? Because here we have 1 plus sine x. Okay. And if I can convert this one into 1 minus sine x squared, then I can apply the identity, it becomes into cosine squared. Then I have a square root, I have a square, it can cancel. Okay, so that's kind of like the basic idea. And let's see how do we apply the conjugate for this specific problem. So 0 to pi over 6. The conjugate, I'm going to multiply. It's 1 plus sine x. Of course, we have square root. Time square root of 1 minus sine x over square root of 1 minus sine x. Okay, and then dx. And then we do a little bit of simplification. So we have square root of 1 minus sine square x over square root of 1 minus sine x dx. And then we have 0 to pi over 6. This going to becomes into cosine square x over 1 minus sine x dx. Okay. So since x is from 0 to pi over 6, that gives us cosine of x actually is a positive number, meaning I can get from 0 to pi over 6 cosine x over square root of 1 minus sine x. Okay. So now things becomes a little bit better. Why? Because for here, if we make a u substitution, if we let our u equals 1 minus sine x, so this is what I am doing. So if u equals 1 minus sine x, and then du going to be negative cosine x dx. We have cosine x dx, so that is exactly negative du. Okay, so far it's very, very good. Now, since this is a definite integral problem, we need to do a little bit more. That is, when x is 0, u equals 1 minus sine of 0, which going to becomes into 1, okay, because sine 0 is 0. When x equals pi over 6, u equals 1 minus sine of pi over 6. Now, sine of pi over 6 is equal 1 over 2. So it's 1 minus 1 over 2 becomes into 1 over 2. So with all of this, we can start to do our u substitution. That gives us is from 1 to 1 over 2. So I have 1 over square root of u here, right? And then multiply a negative du, okay? Because du equals negative cosine x dx. And I just have cosine x dx here. Okay. So I have integral from 1 to half. This is going to be u to the power of negative half. Okay. And of course, we can bring this negative in front. So du. Okay. So it turns out this is going to be so negative, so u to the power of half, right, over half, and then evaluate it. Well, maybe we can put this negative here. Evaluate it from 1 to half. Okay, to half. So we can reorganize this part, which is negative 2u to the power half, from 1 to half. Okay, so we put a half there. So it's negative 2 times 1 over 2 to the power 1 over 2. Okay. And then minus becomes into plus 2 times 1 to the power half. Okay. So it turns out this is what we have. We have 2 times 1 minus half to the power half. Okay. This is going to be 1 minus, it's a square root of 2 over 2 here. Okay, guys, you can work on that by yourself. Turns out we have 2 minus square root of 2 if you make the distribution. Okay, so that completed the problem. Okay, so the trick here is to apply the conjugate. Okay, multiply this, simplify, and then starting from here to do a u substitution, transform the problem into a regular definite integral, and then the student do their evaluation carefully. So I'll stop here and hope you enjoy this video. Thanks.